This is 6.4, and it's about assessing whether or not a data set is normal. So up to this point, you've just been given a mean and a standard deviation and told it comes from a normal distribution. And you're like, okay, it's normal, and away you go. But what if you're out collecting your own data and you need to determine whether or not the data set you have collected is normal? Well, there's 3 items that we would like to be able to use to check if a data set is normal. So the first item that we want to take a look at is the histogram. So make a graph of your data. And if it appears to have a single median up at the very top and tails to the left and the right, and it appears to be symmetrical, it's probably normal. If you have a graph that doesn't look like this, then it's probably not normal. The second thing we look at are outliers. And if your data distribution is normal, it will have at most 1 outlier. If your data set has 2 or more outliers, it's probably not normal. And the way we're going to define an outlier, if you remember back in chapter 3, I think it was, we talked about how you take Q1 and you subtract 1.5 times the IQR. That's how you found your lower outlier fence. And then to find the upper outlier fence, you took Q3 and you added 1.5 times the IQR. And so we'll perform both these calculations in order to find the lower outlier fence and the upper outlier fence. And then you'll use those to check the data set for potential outliers. If you have 2 or more, your data set's not normal. The third thing that we'll look at is something called a quantile plot. And this is sometimes referred to as a QQ plot, a QQ. Now, you will not have to generate the QQ plot, but know that it will be provided for you. So if you have a data distribution that is fairly normal, that looks somewhat normal, your QQ plot will be linear. You'll have a nice string of data points all pretty much in a line. On the other hand, if your data set is right-tailed, in this example, a ball would roll to the right, you notice that this QQ plot is not so much linear. It kind of snakes through that line, and that means it's not normal. Also, if you had a data set that was somewhat uniformly distributed, then you can see here, again, that's not quite linear. It kind of snakes back and forth, and so again, not normal. So these are the 3 things we want to check. Number 1, what does the histogram look like? Number 2, are there any outliers? And number 3, what does the QQ plot look like? So if we take a look at this data set, this is a data set of a geyser in Australia, and someone stood there and measured the amount of time in between eruptions and collected this data set. And the question is this a normal data set? And so the first thing we want to do is take the data and throw it into a histogram. And this is what the histogram looks like. And you can kind of tell, this looks right skewed, right? It doesn't necessarily have tails on the left and right. It doesn't have a single median in the middle. It's not symmetrical. So kind of strike one against being a normal distribution. Then we'll go and look at the outliers. And so here's where, again, we do those calculations, finding the lower outlier fence and the upper outlier fence. And you can see that the lower outlier fence is negative 53.75 seconds. So any amount of time less than or to the left of negative 53 seconds would be considered an outlier. Now, you're not going to have a time less than negative 53 seconds because you can't have negative time. So that's sort of irrelevant. But the upper outlier fence is relevant. If you calculate the upper outlier fence, any eruption period greater than 128 seconds is considered an outlier. And if you go back and look at the data, there are 2 of them, 149 and 169. So because you have 2 outliers, this data set is considered not normal. So strike 2. This is the box and whiskers plot of the data set, and you can see here are those 2 outliers. Finally, if we look at the QQ plot, you can see that here are all of the data points in the QQ plot, and this definitely does not appear to be a linear situation, especially when you consider the 2 outliers that are up here. And so strike 3, the QQ plot does not appear to be linear, there are 2 outliers, and the histogram does not appear to be normal. So therefore, we could say that this data distribution is not normal. So in this example, we've collected the IQ scores of 50 individuals. And again, we're going to ask the same question: is this a normal distribution? So first, you take the data and you plug it into a histogram, and look at this. You've got a peak in the middle. You've got tails that move to the left and to the right. It's somewhat symmetrical. Now, it's not perfect, and it doesn't have to be perfect, but it does somewhat resemble that normal distribution. So we would say probably check. So you've passed the first test. Now let's move on to the outliers. So if you calculate the outliers for the IQ, you can see that the lower outlier fence is 60 and the upper outlier fence is 32. So any IQ less than 60 would be an outlier, and any IQ score greater than 132 would also be an outlier. And if you go back into the data and you look at values that are less than 60 or greater than 132, you'll see that there are no lower limit outliers and no upper limit outliers. And so there's no outliers in this data set. So that's past the second test. So if you look at the QQ plot of the IQ data, you can see that with a few exceptions, there are a couple points that are not exactly on the line, but for the most part, this is a very linear data distribution. And so check number 3, you passed the QQ plot test, you passed the outlier test, and you passed the histogram test. And so this data set is a normal distribution.